Here are your algebra review answers. Now, I already posted a homework help on this. I don't have time to work a single problem today. If you would want me to maybe work one of these tomorrow, we'll have time in tomorrow's lesson, but today, can't do it. So go ahead and check your answers, circle ones that you got wrong or you didn't even know how to begin, and then save it for tomorrow if it wasn't on the homework help. Okay? Good eagle eye there. That should be a Y. Nice eagle eye. This homework isn't something where it's like, oh, I got some wrong, but I'll just get that one wrong on the quiz. This stuff, algebra, it's going to stick with us all year long. So if you don't make it right now, you're going to continue to miss points throughout the whole year. Okay? Oops. So sorry about that. The numbering was wrong. You're right. There is a second number 17 and a second number 18. That one was my fault, not someone else's. That was me. Title your notes, segment, addition, and midpoint. Segment, addition, and midpoint. Title your notes. Now, you're like, wait, we already learned midpoint on Tuesday. That was the midpoint formula. That was if you're given two coordinates, how do you find the coordinate of the midpoint? Now, today, what you really were trying to do on Tuesday, today we're going to talk about the length of the segments. Not the coordinate, but lengths. So today we're going to talk about lengths, whereas on D, AF and BD. AF and BD. Okay, so what's the midpoint of AF? Let's see, 20 plus 14. Plus negative 14, sorry, divided by 2. So this is the midpoint, because it's 3. Okay, 11 minus 5, 6. 6 divided by 2 is 3. Ding, ding, ding. So you found two segments with the same midpoint, because C is the midpoint of BD, and C is the midpoint of AF. To confirm that it really is the midpoint, you could make sure that the distance on the left is the same as the distance on the right. So for negative 5 to 3, that's 8. From 3 to 11, that's 8. Since 8 equals 8, then voila, C is a midpoint. Okay? I think we've spent enough time on this. Was there another answer? AB and EF can't have the same. Oh, AB and DF, those can't have the same midpoint because those don't even overlap. We found the two segments. Good job. Okay, this is a reminder. You don't need to write this in your notes because we went over this the first week of school, but I don't expect you to remember it from then. When we are dealing with numbers, with distance, with length, we use equal sign. Like 7 equals 7. A number equals a number. This is a number, and this is a number. Did I put segments above it? No, I did not. Now down here, this is an object. A segment can be congruent to a segment. So just remember when we use equal versus congruent. Equal goes with numbers, and congruent goes with objects. In this case, it's segments. Which one is incorrect? So I use the correct notation on all of these except for one. I used correct notation on all of these except for one. You got it. Okay, so A says the distance from A to B is 12. There's nothing wrong with that. The distance from A to B is 12. That's awesome. Okay, C says segment HI is congruent to segment YO. Hi, yo. That one's okay because they're segments. We put the little segment bar on top. This one says the distance from M to N is congruent to the distance from O to P. And numbers are not congruent. Okay? The last one says the length of AB plus the length of BD equals the length of AD, which is actually our lesson today, but that one's totally right. Okay. This is a reminder as well. You're not allowed to write this either because it's already in your vocab from Unit 1. Congruent segments are segments with the same exact length. So AB is congruent to CD, which means the distance from A to B equals the distance from C to D. We add tick marks to our figure to show that segments are congruent. That's how I communicate to you and vice versa, that they're really the same length, and then we don't even have to measure them. All right, this is the first thing I need you to write in your notes, so write it down. This is the definition of midpoint. This one you also already had in your vocab, but I want you to write it again. A midpoint is a point that blanks a segment into two blank segments. Good job, guys. A midpoint is a point that divides a segment into two congruent segments. Point B is the midpoint of segment AC. And I didn't even need to write the word segment because that's being redundant because I already put the segment symbol above it. How do we show that it's the midpoint? Well, we add tick marks. Add tick marks and boom, point B just got promoted. Now he's not just a plain old point, he's a midpoint. He has a title now because of those tick marks. Okay, draw me a figure. I have 3 points, A, B, and C. They're collinear, which means they lie on the same line. And B is between A and C. Draw me a picture. Sorry, raise your hand if you put B right smack in the middle between A and C. Raise your hand if you put B in the middle of A and C. So did you have to put it in the middle? Does between mean that it's in the middle? If someone had drawn this figure, did they draw a correct figure or not? So what I wanted to get at here is between, even though a lot of students assume it means in the middle, between just means it lies somewhere on the segment between. I can't define between without saying between. Somewhere between A and C. It doesn't have to be in the middle. So you could have put B anywhere you want. Now, what conclusions could we draw about this segment? If we were trying to find the length of a segment, could we write what's called a segment addition statement? Could we write a segment addition statement? Like AB plus I'm waiting for you. BC equals, just say what it equals. You were typing too fast. Equals AC. Believe it or not, it has a fancy name. That's called a segment addition statement. And there's actually a postulate called the segment addition postulate. I want you to write this down in your notes. This is a postulate. Segment addition postulate, which is just kind of a fancy word to say that it's assumed to be true by mathematicians. If 3 points A, B, and C are collinear, and B is between A and C, then we can conclude that AB plus BC equals AC. This postulate, what kind of sentence, what's the form that it's written in? Do you remember what that sentence is called if it's an if-then sentence? Start with a C. It's a conditional. Yeah, it's a conditional and it has a hypothesis and conclusion. The hypothesis is 3 points are collinear and B is between A and C. The conclusion is that part plus part equals whole. And that's what you'll probably hear me say the rest of the time. So this part plus this part equals the whole thing. So that's layman's terms for the segment addition postulate. Part plus the part together combine to equal the whole. All right. I want you to write this figure, draw this figure in your notes. There are only 3 different problems I could throw at you. So I'm going to show you all 3 problems on one slide. We're just going to talk about the strategy for each of the problems. There's only 3 types of problems I could throw at you today. Take a look at this first one. Segment GO. What do you know about point E? What do you know about point E? Yes, Jane, it's the midpoint. How did I know it was the midpoint? Because of these tick marks. So we're not even going to solve for x. I just want to know what would be the strategy if I gave you GE and I gave you EO and I said E was the midpoint. How would you solve for x? Don't even tell me what x is. I don't care what x is. How would you set it up? Good. You would take that midpoint and you'd put an equal sign above it. Because of course, if I cut something in half, the left is equal to the right. The top is equal to the bottom. However, your segment is arranged. 3x is equivalent to 27. They are the same length. And then you would go along your merry way and you would solve the problem. Next situation I could throw at you. Can you picture me like throwing segments at you? Draw this one in your notes and think about, what would I do differently if she gave me this one? Is E still the midpoint of GO? Or OG? Yeah, it's still the midpoint, so this is still a midpoint problem, but I didn't give you a half and a half this time. Right here, I gave you a half and a half. This time, I gave you a half and a whole. I gave you the half and the whole. So what you don't dare do is say 3x equals 54. No, because a half never equals a whole. So what would we do? So you have 2 choices. And remember, they're inverse operations. You can half the whole, or you can double the half. So you're either going to double or half something. You're going to double or half. You're going to double or half. I'll do a double. I'll do the double just to show you what that would look like. 3x doubled is 6x. 6x equals 54 is how you would set it up. I'm oversimplifying these just to show you the strategy. The algebra will get tougher. Don't worry. I know you were worried about how easy this was. Last situation you could encounter. Draw this last one in your notes. These are the 3 situations I could give you. On this last situation, is E a midpoint? No. So I changed it on you. E is not a midpoint because I didn't put tick marks. I took those tick marks away. So this is not a midpoint problem. This is what's called a segment addition problem. How would we tackle this one? Don't solve. I don't care what x is. How would we tackle this one? Part plus part equals whole. So let's summarize what we did. On the first one, we said the half equals the half. On the second one, we doubled the half so that it would equal the whole. And on the third one, we did part plus part equals whole. And if you can keep track of those 3 strategies, you can solve any of these. Let's go. Let's do it. We have some examples. You get to try to apply your midpoint and your segment addition postulate. Go. This time I actually want you to solve for x. This time we're not talking strategy, we're actually finding the length of a segment by finding x first. Is this one a midpoint problem or a segment addition problem? I know, it's a segment addition problem. I highly encourage you to write the information, write it on your picture. Write it on your picture every time. That way you know which of those is the parts and which one is the whole. Because I'm not always going to give it to you in order. The part, then the whole. I'm not always going to do that. So we're going to use the segment addition postulate. We know that DE plus EF equals DF. Yay. 4x minus 6 equals 30. 4x equals 36. X is 9. Very good. What's the measure of DE? You take the 9 and you plug it in. 3 times 9. Yep. 27. What's the measure of EF? 9 minus 6. You plug it in here. You plug it in here. And you can find all your missing segments. All right, try this one. So what you're not going to do here, hi Angela, you're like, whoa. What you're not going to do here is set those equal. You're not going to say 2x minus 9 equals 28 because we know a half never equals a whole. But it did say m is the midpoint. And please get in the habit of every time that it says it's the midpoint, add tick marks to your picture. Every time, all the time, without fail, add tick marks. Now on this one, you have two choices. You can take 28 and you can divide by 2, or you can take 2x minus 9 and you can double it. It doesn't matter, it's up to you. Normally when the whole is an even number, it's divisible by 2 really prettily, I usually take the whole and I divide it by 2. So I know that 28 means this is 14 and this is 14. So I can just say 2x minus 9 is 14, and I can just solve for that one. What'd you get for x? Good job, guys. X can be a decimal. Don't get scared when x is a decimal. 2x equals 23. So x equals 11.5. Remember, we don't like mixed fractions, so you can do decimal, or you could do fraction. You could have put 23 halves, and that could have been your answer, and that would have been just fine. Okay, good, good. I'm not going to make you plug this one back in. We're going to move on. Okay. A is between R and D. RA is 1/3 RD, and RD is 24. Give you a minute to think about it. Are we done yet? Now, I realize on this one that you don't have to draw a picture, but I like to draw a picture just for those who are visual learners. So A is between R and D. Do not put A right smack in the middle because it never said midpoint. We can't assume. RA is 1/3 RD. So RA is one part of RD, which is 3. It's one of the 3 parts. I'm showing, you don't have to do all this work. I'm showing you too much, but I'm just showing you this could be one of the parts. This would be 2 of the parts, and this gets 3 of the parts. Just showing you a different way to think about it. The reason why this one, you don't have to do this, it's way easier, is because since you know RD is 24, you can just take the 24 and you can just plug it in right there. RA is 1/3 of 24. So the whole thing is 24, and I'm just 1/3 of the 24. So it's just 24 divided by 3. What's 24 divided by 3? 8. Very good. So this one's 8. And this one is, you could take the 8 and you could just double it. Because this one, AD would be double RA. So it would be 16. If you didn't know that you could double it, you could just take your 24 and you could just subtract 8. Because we know part plus part equals whole. So if you have the whole and you want to find the other part, you just subtract it. So what did we do here? All we did was take 24 and plug it in. They're not all that easy, but that one was that easy. Here's one that's not as easy. Try this one. Same idea. We've got segment bro. Just kidding. You don't call it segment bro, but it does spell bro. RO is 1/3 BR. That's different this time. RO is 1/3 of BR. So technically my picture is not to scale. The R should go here. Not that it matters, not that you have to draw it to scale. So what I want you to think about this one as, that made no sense, RO is 1/3 of BR. So I want you to think of RO as the 1 and BR as the 3. It's 1 out of 3, 1/3. See how this is different? We haven't dealt with the whole yet. So this is 1 part, and BR is 3 parts. BO is 40. The whole thing is 40. How would I solve this problem now that I've set it up? The setup was the toughest part. Solving it's now not hard at all. 1x plus 3x equals 40. 4x equals 40. X equals 10. That's not the length of any of my segments. It's just kind of, well, it is for RO. But you just take x and you plug it back in. 1 times 10 is 10. And 3 times 10 is 30. So BR is 30 and RO is 10. The difference on this one is we didn't just do 1/3 times 40. Because see how BO is 40? That didn't fit right here. We couldn't just plug it in right there. So we needed to draw a picture and do some reasoning on that one. Determine the validity. Remember, when you hear things like, what is the truth value, or determine the validity, it just means, is it true or false? If 2 segments have the same midpoint, then they are congruent segments. Hey, thank you. Good. Totally false. Totally false. So we did that on our first slide today. These 2 segments could have the same midpoint, but they don't have to be the same length. What about the converse? If 2 segments are congruent segments, then they have the same midpoint. It's kind of a weird question. This segment, his midpoint is M, but this segment, his midpoint is, I don't know, E. Those AB could be the same length as CD. They have different midpoints. But what if I said, so they're both false is the moral of the story, but it's kind of a weird question. If 2 segments are congruent, would AM equal CE? Well, yeah, because if you cut 8 in half, you get 4. And then if you go to the other side of the screen, you cut 8 in half again, you're going to get 4 again. So the length that you would get by dividing that congruent segment in half would be the same. But would the midpoint be the same? That's a weird question, so we'd say false. Okay, bye guys.